and his nephew. And action.
Action. Okay, do I have any action? Hold
You're in
on.
Hawaii.
What is the definition of a restoring force? Nick?
It'd be aloha.
Oh yeah, you're right.
Nick.
Well, there's probably
restoring force.
Mexicans in Hawaii.
Okay, look.
What?
Listen to Nick here.
I doubt
Josh.
they can get there.
Okay, if I displace my mass on my mass spring system, which direction is the restoring force going to point? It wants to restore the spring to its equilibrium position. And then when it gets all the way up past, which way is the restoring force going to point?
Wait, am I in America yet?
Okay, it wants to return it to...
This is not America.
Okay, so Nick just told me that a restoring force, what, Matt?
What? Pulls opposite of the
That was a good answer.
equilibrium.
Okay, so a force that points in the opposite direction of the displacement from the equilibrium position.
Except relative inference.
And the direction of...
Oh, I'll go
Okay,
fill it up.
so it's always pointing toward the equilibrium position. It's always a force that's gonna try to bring the mass spring system back to its equilibrium position.
Is that sand in there?
Yes.
It took you that long to think of that?
I didn't
Some
know
people
what it
are gonna
was.
use beans today. I hope I have enough mass. A mass spring system is displaced from equilibrium by 34.1
Yep,
centimeters.
I
What
do.
is the amplitude of its
Every
motion?
day.
What?
Andrea, a mass spring system is displaced from equilibrium by 34.1
That's like
centimeters.
the same question. 34.1
Yeah.
is the amplitude.
34.1 kittens?
Meters.
Centimeters. Okay.
Meters.
My
Number
first
4.
grade teacher used to do that. Only she used turtles.
Turtle.
Yeah.
Did she like
I've
kick?
always messed them
Whoa.
up. I
No.
like to twist them.
I would twist them and my
I
mom
like doing
would be
the
like,
stair
I
tricks
just paid
where it's
$1 for
ours
that.
never work
I'm
on
like,
the
shut up,
stair tricks,
mom.
even the cute ones.
Is that my slinky or your slinky?
No, that's mine. Yeah.
Everybody has
You
a
have a
slinky.
slinky?
Okay, so
How old are you?
Can I see yours?
soon.
The
I always
K
break
for that
mine.
would be really tiny.
Or give them
right?
all.
Really
Yes,
tiny.
this is really weak. Very, very small cake.
Oh,
I used to have,
So-
you know they make
hold it on
slinkies
your ear
like
and
8
then
years
drop it
old.
Like this. Let it fall, and it sounds like laser guns.
So if
No,
you,
it doesn't.
Yeah, it's like boing.
You know how light waves are like a transverse wave, where it oscillates perpendicular to
How do they
its...
make slinkies?
It's just a coil wire, but it oscillates perpendicular to its direction of propagation, right?
Right.
A light wave. But a sound wave is like a slinky. It oscillates parallel to its
that where you go back
direction
and
of
forth?
propagation.
Like-
Yeah. So,
Oh!
It's like beautiful.
so this is the only way you can really see that.
You know what it kind of looks like? It
Wave
looks like a
propagating.
tunnel that somebody would walk through to like get to like some secret place.
Except
It's
for they
hard
fall
to get
through
it
it.
to hold still. But I have a
Or it
really
looks
good
like a
video
snake or
of a
something.
really tight
Throw it to me.
coil,
I promise
and
I
you can
won't
see the
twist it.
propagation of a longitudinal
Hand it to me
wave.
after.
Give me an idea.
I'll break it. No, I'm just joking. What in the
Goodness, I
world?
wish you could see this, Sam. They're hanging slinkies off their ears so they can
Sam,
hear.
we know how to read.
The girls will now have slinkies stuck in their
Alright,
hair.
let's see.
Okay, moving
I'm
right
getting
along.
distracted.
Let me see.
Okay, number 4. Stephanie, what condition must be met for a system to exhibit simple harmonic motion? To what? Okay, so Stephanie just told me that to exhibit simple harmonic motion, you have to have what? A restoring force?
Yeah.
That is linearly proportional to its displacement. So a force that's linearly proportional to its displacement. So it has to obey Hooke's law.
No.
Okay? And
This
the
is hell.
proportionality constant that tells you what kind of spring you have is this K. And it's negative because it's always pointed in the direction as to restore.
I said
It's
period is
equilibrium.
Elephant.
independent of amplitude. Is that correct?
Look.
Period would have to be independent of amplitude, yes. And also if you have a pendulum, what's the condition that has to be to exhibit simple harmonic motion?
Wait.
Nowhere?
Because this just says any system to exhibit simple harmonic motion, which would be it's subject to a restoring force that's linearly proportional to and opposite of displacement. But for a pendulum, there's
Make
one
it
more
sound
condition.
It can't go past the place where it like, drops down.
Right, so 20 degrees. I have written 20 degrees here. So pendulum can't have a theta greater than 20 degrees of displacement.
Is that for any pendulum?
So basically, question 9
If you
would
want a
be
pendulum to
It kinda
exert simple
does sound
harmonic
like-
motion,
Turn my ears
then it has
down
to be less than 20 degrees.
so I can put it through.
Number 5, Josh. In a mass spring system, where does the system reach maximum speed?
At the equilibrium point.
I was.
Yes, that's true.
Wait, which Josh were you
Josh.
talking
I was
to?
talking to Josh Haynes,
Oh,
but.
whoops.
Josh Haynes, the cool
We're
one.
going
I'm
this
just
direction.
joking.
Hold
You
on.
can do the next
Alright, I'll ask some
one.
more questions. Okay, so if you have maximum speed at the equilibrium point, Josh Haynes, then where do you have maximum acceleration?
At the bottom.
At the bottom or top?
Okay.
Where do you
Well,
have
so I got it right.
maximum potential energy?
Middle. No, at the bottom.
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 And maximum kinetic energy.
You gotta use the right word.
Right. Oh, where do
Kinetic.
I? Top.
Well, if you have maximum potential energy at the bottom or top at the amplitudes,
Couldn't they both
then
be
you have maximum kinetic
Both?
energy. No, maximum potential energy at the amplitudes.
Mm-hmm.
So kinetic energy is 0 at the amplitudes. It's not moving. It
So it'll be at the
stops.
middle.
At
Where?
the
Oh, okay.
equilibrium point,
Alright.
at the middle.
Can I fill this up? For-
Sure. Use the water fountain. The tap water tastes terrible, and I just poured a ton of poison down. So.
Poison?
You're gonna die.
Let's see. That's everything. Oh, Nick, where is acceleration 0 in a mass spring system?
It doesn't make
Never?
sense. It'd just be a circle.
There's one place where acceleration is 0.
That's like
Doesn't it
Finding
always have
Nemo.
gravity affecting it?
I'm not thinking about gravity, just the mass spring. What?
Equilibrium.
At the equilibrium point. And Matt, where is speed 0?
Speed 0 at the amplitudes.
Yes. Okay.
I don't know.
So-
Talking in Australian.
It's a good point.
I didn't say anything.
Alright, number 6. Andrea, in a mass spring system, where is the mass subjected to the greatest force?
At the
You die.
amplitude.
Okay, greatest force at the amplitude, because
No,
that
she
is
didn't.
when it is at its maximum.
And then
Right.
it's
And
No, she
Christina,
didn't.
in a mass spring system, where does the system have maximum potential energy? Maximum potential energy.
at
Right
the
there.
amplitude.
There.
There.
Okay, I think that's all you were supposed to do this week.
But number 9's obvious too.
Yeah,
I'll fill it up again. It's gone.
we're still doing okay.
It's so
Alright, the
good.
math this week isn't really all that difficult. You just need to know how to use your calculator properly. Okay.
Story.
Number 1, a hanging scale uses the fact that a length of string stretches, the length that stretches is directly proportional to the weight hanging from it. Josh, if a 10 Newton bag of vegetables causes the spring to stretch 5.6 centimeters, what is the spring constant? So, do I have an eraser?
You said, is the spring con?
Yes, what is the spring constant? So what does it tell you in that problem? What do you know? You know you need an eraser.
What isn't the spring?
What problem is this again?
This is the first practice problem, and you have enough time for me to find an eraser. So
It says
think about it.
a hanging scale uses.
You can baby dance in a circle.
It's direct.
Like what?
It stretches.
It's
It
the thing with the
stretches.
ammonia on it.
Hey.
The length of the string stretches directly proportional to the weight of
Right.
the object suspended from it.
Okay, so if the question's asking me what's the spring constant, then what's the equation for Hooke's law, so I can find the spring constant?
What, me?
Yeah, the equation for Hooke's law.
Oh, we just did it.
Yep, we just did it.
This is it similar to y equals mx plus b?
It is. And
So it's F equal K B.
No.
because B is
So
always
that's
0 for a mass spring
At least I
system.
got K.
You have a plus B that's plus
So
0.
on the test, just write K, and she'll know what you
Memorize
mean.
this equation. please memorize this equation. There's one more equation that you have to memorize. I think just
Oh,
one.
and
Hey,
so
when you know the week right before the test when you write all those the formula like that helps me so much.
Good.
When I write them down and then I like the P equals T or the is it
Equals
P?
Oh, impulse is force times time.
No, it's the PVT one.
Oh,
PVC.
PVs.
I don't know what
No.
it is.
Hi.
All right,
Hold on.
focus here, but I'll write the equation.
L equals MRV.
Okay, so what is the problem? Tell me
Equals
my
MV?
force is, Josh.
What did you say?
What's my force in the problem? Number one.
10.0 Newton bag of vegetables.
And I'm trying to solve for the spring constant. And what's my displacement?
Oh, it's just going wrong.
5 point. Josh.
What's my displacement in that problem?
5.6
It's okay.
centimeters.
Okay, so what do I need to do here? Because I know that my Newton is what?
Proportional.
Sounds like a guy on a tightrope.
Is it kilogram meter per second? What do I need to do to my displacement?
Divided by 100. And then
Wasn't
cross
that-
out C.
Yeah, it can't be centimeters.
Meters.
Okay, so
Centimeters
to cancel
never
out the
work.
newtons, I need to
Right.
convert. Alright, so what is my K?
Christina, I need my book.
Wow.
Just hold it.
What's my K?
Here, I'll do it.
K is 180 Newton meters.
Alright, I'm gonna make my displacement -2 because down is always negative, so. What is it?
180 Newton meters.
Downward.
This one, Sam.
Meters. How'd you get Newton meters?
Newton divided by meter,
Okay.
which
Oh,
cancels
that's
out
what
to
I meant.
kilogram per second squared.
Over meters.
Okay.
Kilogram per second squared, which threw me really bad for the first time when I saw it.
What are you guys doing?
Having laser battles.
Wait. What?
No, Matt was just making all this.
Kilograms per Newton squared. I mean, per second squared are just Newton meters. I mean, Newton over divided by meters.
Yeah, because Newton is a
So
kilogram
if we
meter.
got that,
So
we
see your
should have
meters
written-
cancel out.
what if we didn't write Newton over meters for kilograms divided by?
You can write either unit, they're the same.
Okay.
Because a Newton is a kilogram meter per second squared.
Like
and when
number
you
4,
divide
I got
by
5.5 kilograms
No,
per
let
second
me see
squared.
it.
I
That's
didn't get
perfect.
Newtons over meters.
So on the test,
Josh.
you don't write the fancy name for
Give me a
it.
slinky.
If you put Newton divided by meter, that's perfectly correct.
Or if we put
But if it gets more complicated and you
Let's see if we
need
can
to
make Sam
cancel
hear it.
more units, then you need to know what a Newton
Where's the
is.
sound?
Kilogram meter per second squared. Number 2, a dart gun consists of are we, oh my goodness, you can hear it sound, the slinky noise.
You're
Okay.
crazy.
I don't know if you
Alright, a dart gun consists of a horizontal spring, so picture a horizontal spring with a K of 52 newtons per meter. I gotta write bigger. Okay. It's compressed 4.3 centimeters when the gun is cocked. Now, are we going to make displacement negative or positive if the spring is compressed? Alright, if you want to make it negative, then we just have to keep track. What is the initial acceleration of a 75-gram dart when the gun is fired? Alright, so what equation shall I use? Alright, what's Hooke's law?
F equals negative K, change in X, displacement.
Okay, and what, if I know mass, what am I going to call force? What's Newton's second law?
I forget.
Are you kidding me? Newton's second law? I'm putting this on the final.
No way.
Energy cannot be created.
No,
That's the first one.
That's
That's
the law
a-
of conservation of energy. It's not even Newton.
Is it for every force?
F equals
Oh, MA.
F equals ma. So if I have
Which
force
means
here, I can just substitute that. Right? Okay. So, what's my, the question is what's the initial acceleration? So that makes it convenient to solve for acceleration. Alright, so I've got mass of 75 grams, which I probably want to convert. So what is 75 grams in kilograms?
0.075.
0.075 kilograms. Okay, so times acceleration. So mass times acceleration equals negative k, so negative 52 newtons per meter, times displacement, which we called negative since the spring is recoiled, negative 4.3 centimeters. So our two negatives cancel out, and then we do 52 times 4.3 divided by 0.075. And what is that? Anyone have it?
What question is this?
I think I
Number
failed
2.
this one.
I do.
I don't think I did this the same way.
I got 30.
Never mind. I didn't fail it then. I got
Let's see.
29.
52
So
times 4.3 divided by 0.075. Now see, I round it to two significant figures, and it rounds up to 30 for me. Type it into your calculators again and make sure.
hang on, Sam. This might be bumpy.
Well,
Figure? Yeah. 30?
oh, the centimeters need to get converted. Hold on.
0.043.
Okay, so
Yeah, it's definitely 29.
it's what?
It's 29. Here, do you want to go see?
Yeah.
I might have rounded.
Oh, you rounded in the middle step. Okay. Like you did this and then rounded and then divided.
Yeah.
Okay.
Okay, so that works then.
Alright, so if I saw that you set up the problem right and I got 30 and you got 29, we'd be okay. So acceleration is what? Scalar, vector,
Vector.
vector.
Yes.
So what do I
Victor.
need to do? Because I got a positive. So what do I need to do to make sure that I fulfill my vector requirement here?
You say
Yeah.
in the negative direction.
Compression.
What?
I wrote opposite
Good.
direction of compression.
I didn't hear you say opposite. So it accelerates opposite direction of compression. Like that. They're really making good progress in the new building, Sam. Can you hear it?
I know, I saw, oh my goodness. Stop pointing that camera at me.
You're talking.
If you're talking, you get pointed out. Alright, so if you had not made your displacement negative, and then you got a negative acceleration, what would that indicate?
That your dart gun has been fired backwards by accident.
Still opposite direction of the compression, so you would still have your acceleration vector telling you something useful, right? Make sure that you put that into words. Number 3, a 50.0 gram puppet bounces on the end of a loose spring with a very small k, 1.5 newtons per meter. What is the period of motion? So we have an equation for period. Does anyone know what that is?
Oh, it's T equals 2 pi times radical mass divided by K.
Okay, this equation is your new best buddy in this module. Alright, so it tells me my puppet is 50 grams. And my period's going to be in seconds. So I'm probably going to want to convert. Do I want to convert? Yeah. Alright, so my mass is going to be in kilograms. What else does this problem tell me? What's my spring constant, Matt?
1.5 Newton meters per meter.
And what else do I know?
You don't have the way. Yeah, that's all they give you.
That's all I got. Okay, so 2 pi times the square root of 0.050 kilograms divided by 1.5 Newton per meter. What do I get? Well, here's where I have to fool with my units. So I have kilograms divided by kilogram meter per second squared divided by meter. So kilogram divided by kilogram, and then I've got a second square in the denominator of the denominator, so I end up with second square as my unit inside the radical. That's good, because the square root of something squared is a happy number. So,
What's after, like, can we get to the number, like, do scientists get to the number, like, after trillion?
yeah, there are
What
lots
is
of
it?
numbers.
What do they call it?
Quadrillion.
Is it?
Yes. Because tri,
And there's
3,
also-
then quad, 4, then quintillion,
Yeah,
5.
Google Flexes, one with the Google and 9 zeros.
Google is one with 100 zeros.
Or
Yeah.
a million. No, it's 100.
Google is?
Google.
I don't even want to think about
1
it
times,
that
it's
way.
1 times 10 to the 100 with the 100 zeros after it.
That's crazy.
So long.
Alright, so anyhow, can somebody do this much less terrible problem than that? Or do you have an answer?
Answer is 1.1 seconds unless I did something wrong.
Somebody loud?
1.1 seconds. Most calculators
Okay,
can't
we
do
get
Google.
seconds 'cause we end up with seconds squared, taking the square root, we get seconds. That's what I got too. Yay.
I got 1.1. Wait, no, 1.2, I mean.
Oh,
Oh, you failed.
Just change it to
Hold on.
1.
who said that?
I think I got 1.2. But I guess it's a computer thing.
It would be
Josh,
0.05
what did you
divided
get?
by 1.5.
I got 1.1.
I got
Square
nothing.
rooted times 2 times pi. Did you use 3.14 for pi or a pi button?
I use the pi button.
You should have gotten it.
Did you square, is that
Close, though.
second
That's
squared?
almost 1.2.
Is 1.2 your second squared?
5.
No, you just take the number and the place below the one you're rounding to. You can't round and round, you just round one time. So if it's 4.7, it's still a 4.
So I was wrong with the calculator.
Nope. Always round just with the place below the one you're rounding. You can't round that one and then round the one above it. Number 4, a 0.4 kilogram mass is attached to a spring and set in a simple harmonic motion. If its period is 1.7 seconds, what's the spring constant? So again, we're going to use that period equation.
Otherwise, 3.45 would be 4.
And let's see. So where am I going to plug stuff in?
In there, MK. Wait, what do we have? We got M and T, so we need to solve for K,
Okay. So
which
what's
requires delicate maneuvering of square roots.
T? Oh yes. What's T?
T
Everyone's gonna do
is
this on their own calculator.
1.7 seconds. M is 0.400 kilograms, and then K is to be determined.
Okay, so I want everyone to solve this 4K on your calculator yourself right now.
Matt, Josh,
Yeah. So
do it.
So what I would do is I would take 1.7 divided by 2 divided by pi, and then I would square it, and then
Got
I would
5.5.
convert that and multiply it by 0.4, and I get the right answer. Hooray!
They've only been doing that building for what, like, maybe
Not long,
2
yeah.
months?
Plug into your calculator.
What? Nick, I thought you were.
I would see every person get this answer for K on their calculator.
Otherwise, you will
Just the
fail.
bottom line, just do the top line.
Just solve this for K.
Look at it carefully.
Don't yell at me.
Sounds like Jimmy.
Wait, oh. Wait,
Ah, mine's messing
how do I
up.
do that?
Mhm. Okay, so
No.
I do that.
Well, I
but
got
I do
it.
the second, the
if you
right
do
side
some
of it.
writing, you do this: 1.7 seconds
Mine's
times
messing
well divided by 2 pi, right?
Pay attention,
Equals
Sam.
The square root of this.
Where's the pi button on this thing?
It's right.
All right. Are you with me as far as this?
Stop. Yes.
Oh no, 2 pi equals. Wait,
See,
why
I
do I do
divided-
the equal thing?
I divided both sides by the 2 pi. That's all I did. I just moved the 2 pi from the
He
numerator
did
here to
differently
the
in
denominator
both.
here. What?
He
Yeah,
did
he
differently.
did it really weirdly.
He squared both sides so you could get rid of the.
That's
Well,
what I did.
got
That's
to
what
square
I
both
always
sides.
do.
But well, he didn't move the 2 pi over
Josh, see.
underneath. He
Well,
just.
then he doesn't know what he's doing.
See, this is what I do.
Then
What
I
did you
would do
get?
That.
Right answer.
And then I'm done with the radical. So I'd have this times k equals, then I'd have that. Then I'd solve it for k. K equals I'd end up with that. And I wouldn't round ever until I plugged the whole thing in and got an answer.
Did you get that, Sam? If you didn't, you can just rewind it.
But Dr. Wow probably rounds at every step, making everything crazy. Alright, so if somebody has got it done, what did you get?
5.5.
I got 5.5
Me too.
Kilogram second squared.
Yes.
kilogram per second squared. Is that what you just said?
Yes. It's Newton divided by meter because the meters cancel.
Okay. Or Newton. Like that?
Right.
Okay. And that's what I got. But all of those graphing calculators are weird. For me, I just type in 1.7 divided by 2 divided by pi, square that, and then I hit the 1 over button, so I end up with that in the denominator and multiply by 0.4. But can
Do you know what
everybody
it smells
actually
like
get that
there?
answer? Yes, we use a lot of vinegar in chemistry.
And ammonia.
What?
And cabbage juice.
I
Can we
smelled it when
die
I
from
came
that?
in, but it's gone now.
Your nose is desensitized.
Does this actually happen?
Okay.
Yeah.
If you practice that problem before the test, make sure you know how to type that into your calculator and get 5.5. And then basically the same problem except you're solving for the mass is the next one. And does somebody want to just tell me the answer for that?
Fascinating. Wait. 0.292 kilograms.
Nick, you got 92? 0.92 kilograms for number 5. And let's do a lab. Okay, so your goal today is to find the spring constant K for your personal spring. So we'll do it in 3 groups, I seriously hope.
And I have a spring.
And everybody can pick a spring.
I know which one I'm taking.
Toss them here.
I pick.
Can I get a
Yes, we
thick
get the
one?
best one.
I want a thick one.
You
No,
want a
you
heavy
can't.
spring?
I'll use my water bottle.
Stephanie, do you concur with this decision?
don't care.
Mine
She
is eye
doesn't
length.
care.
How long is yours? Mine goes to the corners of my eyes.
Alright, so you need a mass that way more than displaces it by half.
Can I see
dude.
that one? I want the little tiny one.
This is
No, you
hard.
don't. You
I don't
want
want
that
the
one.
That's ugly.
Or eat
Okay, so you
Can I
are
use my
going
phone as
to
mine?
first do a test on your spring. You're going to hang a 650 gram mass from the end of your spring. If your spring doesn't double in length, your spring is not good.
This spring
Probably-
triples in length.
With a 650 gram mass,
With,
it must at least
I don't know.
double in length.
Ow! Sorry.
I'm not letting him have that spring.
No, that was the other. Yeah, that's the non-powerful
So
one.
this is 665 grams.
What happened?
Nothing. I'm okay.
Which lab is
So
this?
you're starting
10.1.
with 665 grams, guys. So you're gonna write that down.
You
'cause
already weighed this?
It's supposed to be 650. It's currently 665.
Oh, I left my string at home today.
Is this
Of all the
10.1?
days.
All right.
Do you have extra string?
Do I have extra string? I have lots of string.
Can I borrow some?
Yes.
No.
Check. What experiment is this?
This is the first half of 10 something. Yeah.
So it's 660.
Some sort of. Well, no,
Ooh.
you're gonna weigh out yours.
Ooh, where do
Math.
What is this?
Yeah, I don't know. There's springs. Springs. All right, so tear yourself and try to get as close to 650 grams as you can.
This is the
Okay.
Hook's Law one?
This is Hook's Law.
So we're 10.1.
Wait, what are we getting?
10.1. But yeah.
Does it matter if there's sand in the bottom?
Nope, doesn't matter.
How
You
many?
just want mass.
660?
600 and, well, I'm looking, 650,
Oh,
I
look,
think.
it's working on my phone. Oh, we have 140.
I don't even know if I wrote it down anywhere. Sam, are you still watching this?
You're gonna throw it in.
Yes, Sam is still watching this.
Ours
Sam.
is fascinating.
That's what I want.
Nope.
Sam, if you would like us to just skip to the end, you can tell us and we'll skip.
What is that? Those beans?
Beans.
Okay,
It's only
Sam's
one
good.
side in the
He can
pantry
keep
today
watching.
besides your Sam. So for an extra loud group, I needed another
No,
mass.
I'm not eating those beans. Matt, you're crazy.
All beans need to be washed before you cook them. They're all covered in grit. They grow in the ground, you know what I'm saying? So, like, they don't actually wash them successfully. So if you
630.
cook them without
What are we
washing
doing?
them, they taste like you're eating sand, which you are.
What is our number supposed to be?
650, I
I'm
think.
not
I'm
eating
looking.
those, man.
650.
You can look at
No.
10.1.
Who even eats beans? Not me. I like
Here.
beans. Yeah, green beans.
Carefully, and
Yes, 650 grams is your
See, all
first
the
measurement.
green- the beans in them, don't.
oh my gosh.
It's fine to add
These
and
are not
subtract.
green beans.
No worries.
No, those
Another
beans.
Oh, here, you'll have.
Look, I got it
It
perfect.
goes off being like that big.
Those go to the ground.
So did they?
Aw,
Shut your
man.
mouth.
Okay.
Do green beans go on the ground?
Yes.
They grow on a plant, but the green beans don't really
Alright,
touch the ground
wait,
if you
so
leave
did
them
you-
for
Have you
10.
ever picked green beans?
Yes. Like a green bean, like.
They grow
Okay,
on the
so
ground.
once you've got your 650 gram mass, you have to figure out how to suspend your system.
You eat it.
From that?
So I would hang this over the edge, unless you want to
Alright.
use some rulers, and then hang your mass spring system from the ring. Here, you two want it between you. Okay, so that will stick out over the edge, and then your mass spring system can bounce there
This might
without
be a
hitting
little bit
the
too
Kind
much
of
weight.
wobbly.
Yeah.
Let's try
Well,
it
it's
like
not as
this.
wobbly as this.
Yeah.
Very smart.
Okay, so what are we
Let's
writing
see.
mass?
Wait, hang on. We need to see. Hey, we need that scale when you're
You
done.
guys are going to use one of
Bag.
these,
Do you want
I need to
us
drink
write
some of this
the data
down.
and everything down? So
Yes.
we'll be using it next week, right?
especially.
Wait, do you have another one of these?
Hold on.
650
I might.
what?
You guys,
Okay, I'll fill it up in a second.
Can I have that
Hold on.
scale?
if you guys want it to be exactly 650, so you don't have to do extra math, then go
Yay!
ahead, take
it's
some out
6:30.
and. What is it?
Well, the string.
Yeah,
Oh,
or
yes.
the-
No, no, you want to weigh that too because it's going to be on there.
Wait, hey, we need another one of these hook stuff. See?
No, you don't. Use rope,
Hold on.
string, whatever. And give me the scale.
What's the mass?
671.
Okay, so take it down to 650 so you don't have to do
How
extra
do we
math.
get this on
So
there?
just pour out 20 grams into the bag.
Oh, Christina.
I think I
Okay, so
shouldn't have
Liz,
drank
you're
so
gonna
much.
work on suspending
Don't we need
your mass
another?
spring system.
Don't we need another one
So you're
of
gonna
these
weight the
things?
end down with
Well,
rope.
that's sand.
You want to
I like
keep it
sand
from
so
flopping by having as little as
Sand
possible.
tastes
What,
good.
do we need 2 rulers then?
You need one ruler to measure length and one ruler to suspend your
Okay.
system from the tree.
Wait, where'd you guys get the beach to get this?
No.
Mrs. Matthias, how are we supposed to dangle this from this thing?
Hold on.
You gotta hang it off the edge. Put a book on it.
I wonder
Yeah,
how many
paper
grams
cut.
of sand.
I need a scale.
God, please tell
He
me.
needs to scale. Did you
A
get it?
paperclip will work.
Alright, let's see this.
Hold on. The scale's coming.
Ours hits the ground.
Yours hits the
Raise it up
ground.
to the
Raise
top,
the
look.
rope stand.
This little thing, yeah.
Wait, you got
Righty tighty, lefty loosey. There you go.
Ah, a little bit.
My dad always told me never to say that.
Why not?
Why?
Cause he was never a fan of mantras and like not mantras, but like things to help you remember things. He's like, why? Learn them, just learn.
Well-
What'd she say?
Oh, I
Not
love
say what?
things that help you
Righty,
remember.
tighty, and lefty,
It's
loosey.
easier.
No way.
Oh, you guys need a
I
paper clip.
secretly said it in my head though.
Well, yeah, because
Your dad said not to say.
Of course, then you get like the negative threads, and it's like lefty tighty, righty loosey, and then you're like, what?
Lefty, tighty, what?
The
don't
negative
confuse
threads.
them.
I don't
Righty,
know.
tighty.
I mean, I know that righty, tighty, and
But not-
lefty, loosey. I know.
Most things. that
Right.
you-
Put a book on it.
I'll hold it.
Work.
That'd be boring. Sam, does that look dumb or does this look smart?
I know most good.
She's turning.
They just.
See, I thought so.
Is yours too low?
Thank you, Sam, for agreeing with me.
651.
Sam thinks
There you go.
Yeah, I think we're gonna.
girls rule
Isn't
and
that good?
boys
You're not trying to
don't just say.
Well, too bad, Sam, because you're wrong.
See?
So there.
Ah.
No, just take it a little bit.
Andrew's wrong too.
Nick doesn't even flinch. Is that
We're all equal.
Yeah, Nick ain't scared. Look.
Actually, people hitting me with.
So what are we
Oh,
doing?
brothers.
You're being videotaped.
Is your little brother or big brother?
Let's help it out.
I need a scale. Joshy.
Scale. Is it 650?
654.
Hey,
Because this thing keeps on
Oh,
falling.
you
That's
don't
not
need.
counting.
Yeah, you don't want to weigh the spring.
Oh, really?
You said for us to look right.
Yeah,
Yeah,
I
my
wanted you to
ours.
weigh the
Ours is
spring.
clearly the better
Spring
one.
ring.
No, it's
That's
okay.
good. It's good. It's good.
So we
Like,
put
like
down
a workout.
Oh, thank you.
How many?
So it's 650.
650.
Where's the spring at?
Okay. So what you're gonna do is you're gonna measure
Where's the hook? Where's the hook? Hook.
measure the length of your spring.
Hey, we lost our hook.
From when?
This thing.
From when? From when it's completely taut?
Somebody.
Did I really?
Where's it still in the bag?
Oh, it's on the floor.
Excuse me, people.
Okay.
Where'd it go? Are we here using kilograms?
We're gonna use.
haven't had
It's
carrots
just
in like 2 days.
closed it all the
So I
way.
just write down.
Finish them off.
Okay, so you're gonna do all the rest of the conversions, but
Big
if you
one.
have 650 grams, how many newtons of force will
But you
that?
can't hold. You can barely.
Wait,
hold
but
this
we
like
what do we
this.
don't? Wow, we don't know what to measure.
Okay, take your weight off your spring. Everybody just have your spring hanging there.
It gives you 6,040.
Okay, everybody
600.
hang your spring from your thing.
Or
That's
touch the
That's all
ground.
confusing.
It's hanging.
So we need different
Wait,
spring.
you guys are using the slinky?
No.
Oh.
A different spring is gonna work for
It
yourself.
would be the bag would be on the ground.
Okay.
If we hung it from 30 feet, the bag would be on the ground.
Yeah. However long the slinky is.
If we stretch it out, it's
I
probably
dare
30
you to
feet.
sand. Maybe $1.50.
You won't be hungry for the rest of the
Okay,
day.
75.
$1.75.
Okay,
Right, you're gonna wanna do
$300.
that.
To eat all the sand?
Dude, I would eat.
You won't be
No
hungry the rest
eating
of the day.
sand.
I would
There's
eat.
filling.
I would
You
eat
need
all that sand for
650 grams.
$300. Who wouldn't?
All right, so once
I
you
don't think
hung
I
your
could eat
spring
it.
up,
I don't
measure,
think I could
don't you
swallow
dare
all
use
that.
that.
This one?
Measure the length of your spring when it's not
This is-
attached.
this is the s-
$50. I
the-
would do it.
Loose one.
Lucy spring?
Yes.
If you want Lucy spring, then you need a
I would just
650
have-
gram
I would just
without
have
the
a bunch
spring
of
mass.
You can.
You couldn't eat all that sand.
If you use that, you're gonna have to
You know,
do the
there's
math.
little kids at the beach
Which is
that
fine.
That works, yeah.
That much sand.
Okay.
687.
No, like,
Yes.
you get a time in your sand in your mouth. That's disgusting.
What?
$650.
I'd rather
How
eat
do
a
I
bunch of like
convert-
snakes or bugs.
Okay,
What?
2 things. How do I convert kilograms to newtons?
You multiply by gravity.
Multiply by gravity.
Or gravity.
You keep that
I
switch.
know.
Okay, so how many newtons would this be?
9,400.
I already gave you some.
I
You
mean,
did?
6,400.
Give me $1.
Oh, you already did. Give me another dollar.
Okay. I get 6.4, and you have to round to 2 significant figures for every single force measurement because of gravity. Okay, so 650 grams is 6.4 newtons. Now, what you're gonna do is you're gonna take your spring, take your yardstick, There's a yardstick, Nick.
Uh-huh.
You're going to measure your spring in centimeters. You're going to measure it, not the hook part, but just the first coil of the spring to the last coil of the spring. Measure the length of your spring.
Measure the length. Nick.
So like, and measure between the lines and stuff. Measure properly to as many significant figures as your ruler can give you. 14.1.
This is the best.
Do you know how hard it is to tie knots with only one thumbnail?
Stephanie, I want to help you out.
I could try.
She has little fingers.
1 second, I might have
Ours
it.
is almost exactly
8.
9.5. It's like 9.6 centimeters.
I did that.
Did you measure the length of your spring and write it down? Write down the length of your spring. Don't stretch it. Just measure
I
it
got
out.
9.6, but tell me what you think.
I'm 0.
Oh darn, I tied it too short now.
Where's the camera?
Right here, watching
Yeah,
Andrea
you're on.
drink her coffee.
Why do you have it on?
It's tea.
Whatever it is, it's watching you drink it.
Is it hot
I
tea?
drink it sort of like a retarded person. Like,
Okay. So Sam, ooh, did I just hit a button? Nope, it's still going. Okay, so look, Sam, Nick has measured the length of his spring. What is it, Nick?
Tardisaurus Rex.
Like
I used to call
10.1 centimeter.
Okay, so Matt's writing down 10.1 centimeters. Now hang your mass off of it. So once you've measured your spring, you hang your mass off of your spring. So
That's what they eat.
yeah.
Tardisaurus Rex eat dog food.
Oh, other side.
Duh. Some of the poor ones eat cat food.
oh, the very first
Really dog
little
food.
thing. I measured for
This
this
sounds
one.
big.
Here, let me just. Why don't we just lay it on it?
I'll have to mail Sam a spring. You two pay attention. Okay, now you're gonna measure the length of your spring with the weight on it.
You liar.
So we're gonna raise that up again. Sorry, ladies, we're stealing your book.
It's fake. No, it's fake. You've never done it.
Okay.
I know.
Who knows what Sam is seeing now?
You seeing Josh spit on me.
I
He
did not
didn't
spit
probably
on-
see that.
I
Darn.
did not. It's crazy, man.
I don't think I can lift the pile of books anymore. If I have to do it again, Matt, you're lifting the books.
How many books do we need?
Who has a book?
Oh, I have one in my backpack.
Oh, Andrew got a shoe like.
Andrea, just
We're
give her.
using
Give.
We have to raise up their experiment because it
Josh,
keeps
give us
hitting
the
the
book.
floor and they don't have a ring stand. They need that book. Does anyone have a book? A book? A book? He's got a book.
Okay, put it on the.
Sam will be
This
ill.
was it. It was P
Oh,
equals
great.
MV was what it was. Oh no, but this
Homework.
isn't the
I
homework.
put it at like 5 times.
Oh, listen, guys.
P equals MG.
I have another book.
Okay, we might need it. Ooh, looks fun.
Hey, that's my.
I love that book. Does it really hit the ground? Here, we need it.
I'm in
Sorry.
biology.
Christina's knocking out 2 science credits in 1 year.
Wow.
Guys, I had
Okay.
extra periods. I was like, I don't like studying all this.
Study hall.
It's just like,
Sometimes I just.
Ours-
This is what I do in.
Ours,
Sorry,
ours
Sam.
touches the ground too.
Wait, I think I have.
it's like
Yeah, you're gonna have to raise it
Bring
up
the literature
somehow.
book.
No.
Actually,
Get
it's,
it.
We're not. We don't have literature.
it's actually not touching.
No. Why would I
Does
need?
anyone else have a big book?
Is it really not touching? Okay.
No, but when it falls, it touches the
Oh
ground.
yeah, when it falls, it's gonna touch.
No.
Well, it's okay. At its equilibrium point, is it touching the ground?
No.
Barely not so much.
Yes, it will. Watch.
No, actually, it doesn't.
Okay, so measure the length of your spring
By
now.
like 1 centimeter.
So once you have your mass suspended off your spring, you have to measure the equilibrium point.
Hey, Andrea.
This is one lab that makes it completely worthwhile to take the class here and not at home. Poor Stephanie. How do you put up with this?
Just barely. This
That's
is even less
just
than-
barely was the answer to that question, I think. All right. So if your spring has not doubled in length with that mass on it, it will not work.
Consider it.
Thank heavens Nick is doing something.
Yeah, Josh.
So like right from
I looked at other books. That's
Okay, Nick is measuring the length
Come on,
of
Nick, you
this
got this.
spring.
Motivation.
Come on, man, come on.
you're the lowest person in the group. You have to do all the work.
Measure.
You can do it.
Anyone who's bored can figure out that, well, no, we have every book piled up, so I guess I'll tell you all these things.
What is it? You said subtraction you learned in elementary school.
What's 9 minus 3?
What's the current length?
I don't even know what 9
Nick, did
minus
your
3
hat say
is.
chocolate?
6.
Yeah, it says chocolate.
Really?
What's the
Chocolate
current
skateboards,
length? Current length,
chocolate hat.
current
Is
length,
it really? So it's like a
No,
sword?
not like
Chocolate.
current length of spring, ladies.
I was right. I told you. I was just the H and the CH and man, I am.
Josh has now snapped his fingers into the spring.
It's the same.
Okay, what's the
64.
64? Matt, 64.9. So, when the mass of the hanging off the spring is 650 grams, which is 6.4 newtons, then the length is 64.9 centimeters. Upside down.
Or can you just
Sam
upside
can do a
down, Sam.
handstand to see this paper.
Or maybe backflip.
Backflip.
And then freeze time with his watch. There you go. There you go, Sam.
So,
Oh no! It's a wand.
all right. Has everyone measured the length of your spring?
Our string just broke.
All right, measure the length of your new
Experimental error.
spring.
Wait, but this one's gonna be sick.
What is this
Not
called?
even a chance.
Twirl or switch the
All right, stay with us, boys.
Did you watch that on YouTube? So,
Are you a class worker?
Okay. So if your spring doesn't double in length, it won't work. Now what you boys are gonna do, since you are at it here, is you're gonna use the other mass measurements. The other mass measurements, which, is that my book?
The thing is, now, Mrs. Matthias, ours is gonna have to be a lot taller. Does the string
Okay,
longer?
I'm just gonna write down the other mass measurements since all your books are now piled up.
What books are whose?
I have no idea.
Put a book on
Mine
it.
is the one with the
mine.
rip on it.
Mine is the
mine?
one that's.
Alright, let's only drop it once and then just, if it hits the ground.
I don't know.
There's the biology book. Mine has the rip on it. Josh's has his name in it.
Mine
Has
Does it hit the ground?
No.
No, it doesn't.
Mine was the second book in the box.
Here, but I
Is this my book?
One of those-
This has to be my book, right?
One of these is one of these here and one of these is mine.
Okay.
And this is Josh's.
What happened? Chemistry?
Yeah.
Poor Sam.
We got a problem.
This ridiculous stuff. What is the
break?
problem?
Okay.
Listen.
No, no, look, we're not
Do you
ready.
have 5-minute warning?
No.
But anybody who's in American Lit, if they could see me before they leave, when they get out of this class, you know you're not having class today.
What happened to my spring?
I know, I'm
But I have
sad.
your homework,
Oh,
so.
okay.
you
Ooh,
should see me.
homework.
I just stretched it out.
We just let it
Spring is
hang.
malfunction. Okay.
Oh, okay. Ours
I quit with this spring because it's just twisting. It's like untwisting.
I'm gonna use the other one.
Pay attention, guys. We have 5 minutes and not nearly enough time.
We're singing our song we made up.
You made it worse.
Yeah. Oh, you guys are gonna get slapped by Miss Matthias.
Yeah, because I'm the best teacher ever.
80. Whoa, look, it makes a circle.
No, it doesn't. 8:45.
Okay,
What are these cat things?
so super fast rundown on what you're about to do.
65.
Okay, you need to take a measurement of your displacement at each of these masses. So sharing one scale and maybe decreasing to 2 lab groups. You two join
Wait, we
another
have to
lab
do this
group
in the
right
5
quick.
minutes we have?
Yeah.
Yours work.
So here's
Can
the
we
thing.
use yours?
You have to decrease
We'll just-
your weight
'Cause
and
this
take a
one's
measurement. Okay.
Hard, and this
So-
one's too stretchy. Look what it did. It's hurting.
All right. So Stephanie, you join the ladies, and Josh, you join the guys.
No, Josh can join us too. They can.
Oh, that's
join
fine.
us.
4 is fine.
Oh, you guys
Yeah, I
want
quit.
Josh?
One of you has to have
Got
four.
yours out.
Okay, so you're gonna have to share the scale,
No.
decrease your weight by 100 grams. I gave you the math here because all the books are being used. You can't do the math.
Okay, guys, what's up?
I don't know.
Where do you go?
All right, so you're suspending.
You're on her.
What are
Take-
we suspending?
So do 650 grams, get the length of the spring. 550 grams, get the length of the spring. 450 grams, get the length of the spring.
You know, this is failed.
We haven't measured the first one.
There.
Measure the
From
first
this?
one.
We didn't know what to do.
First we
We
have to
just
decrease the
hung
mass.
Oh, you already did.
Okay, did you measure the length of the
What was
spring?
it? Was
Yeah.
650?
Okay, now measure the length of the spring was 650 grams.
Like from here to the ground.
Yeah.
The length of the spring only, not
range.
Deep
anything
sea
that
fishing
you
is called four sharks.
Hey, Matt.
How long is the string?
Will you look at the bottom?
How long is the
you know?
string?
He asked me if I've ever gone fishing.
0.101.
49 and a
I
half.
have
49.5.
I went deep sea fishing.
Zero
caught
point
four
one
sharks.
zero.
This is so awesome. Dude, I did a whole
Meters?
like,
Yeah.
don't suspend your mind from anything ever. That's always
When it's
bad.
not
Is it really a bad idea?
When-
No, the with
when
the
it-
zero
when
is
that's right.
meters.
Okay.
0.10
Let's
meters.
see.
Hey, have you ever heard about have heard about
Stress
this is a good thing for this experiment if you watched one of the videos.
0.649.
Have you ever seen one of those slingshot things? The
Slingshot.
And the length of our spring is
it's a
14.
roller coaster and you get in this like ball and they
Okay,
shoot
got that.
you up and they slingshot you in there and there's two
Josh,
posts.
do you see that beaker?
Oh, yeah, that's
The
fine.
little tiny beaker, not a flask, but a beaker.
Here.
Alright, so now
We need it with this.
With the sand.
Look at this.
The beaker, the squarish guy.
Oh, right
That-
here.
That guy, thanks. Let's see, here, maybe you guys can take out 100 grams of this.
One was a black tip.
No,
Yeah,
we're lowering
here.
it by 100.
That's it. And then
Josh, use this scale. You can just put 100 grams in the beaker.
Gelatin.
All right. Pay attention, guys. You have a measurement.
Killer.
Yeah. Try to get it all into the beaker if possible. You need a
Oh, I'm
scooper.
going fishing.
Get another hat.
For your phone?
Yeah, I wish I could.
So, who has a class after this?
Bait app. That would be so funny. And it, like had a picture of a fish on it.
Ooh, while you guys are measuring and stuff, here's what you're gonna do at home. You're gonna graph your force and your displacement.
Anybody get a knife
Okay.
in their pocket?
It tells you in the book, but here's how you find K. You gotta know this because you have to do it at home.
Listen, listen.
Take your graph paper, graph. So you've got.
43 and a half?
Hold on.
43.
Is it- I want to know which one's the x-axis. Sorry. He braces himself. As I
This
draw.
wasn't held on.
Nothing hanging off of it. Good. All right. Displacement versus
Delta
force.
P is impulse.
All right. This. So you're gonna do a graph of this. Okay. So your force is gonna be like these measurements here: 6.4, 5.4 newtons, 4.4 newtons, all the way. Okay. And your displacement, you're gonna graph. You're gonna get a straight line because F equals negative K times displacement, right? The slope of this line is negative K, or is K, the spring constant. So to find K, you just graph your data, the length at 6.4,
It tastes like salt.
right?
same.
So 6.4 newtons, whatever the length is, you graph it. You get a straight line, you get the slope of that line, that's your spring constant. You need to know your spring constant for next week. And we'll obviously use two groups next week since we can't get
Is this 40.4?
more than two springs to work.
440 grams, not 450 grams?
This is
450.
It should be 450 grams, which is 4.4 newtons. Because I did the math for you because I'm nice. I multiplied by 9.8.
Oh, look at that.
8.
Oh, it is 450. Sorry.
Is it measured?
Make sure everyone has a copy of the data because everyone needs your own graph.
That's really simple, 3.4.
When did I come over to you?
56.
We can call you, right?
Yeah.
Can we do
Just-
labs?
But just remember to graph force versus displacement. Force on the y, displacement on the x, which is easy because x is on the x. And now
I
I
can't
might
even remember what the lab we did last week was.
It was just write up a report about the Newton's cradle
What is it?
and why.
56.4
I wrote that. Is that okay?
Perfect, absolutely.
Whoops. I just dropped
You
it.
never make us type anything.
You don't ever have to type anything in my class, but if you know you make a ton of corrections and I keep handing it back over and over and you don't feel like handwriting it over and over, then
It
typing
may
it would
be
be your
more
best bet.
practical to type.
Don't.
38.4.
Okay.
You can use this for your cat.
38.4.
What was the second one?
She really could.
Alright, wait, where's our
What was
bag?
the second?
We need
What was the
350
second
now.
link
Or
for the?
450. Second what?
The second link. You did the 550 grams.
56.4 centimeters.
Now we need to take out another 100.
This is gross.
Sometime you're gonna try that. It's actually gonna be
Yeah,
It's gonna, no, this guy did it to me at work. I was like,
Pay
what?
attention.
Hey, watch out, watch out.
I like how Josh joins your group and he starts doing them.
I'm writing stuff down.
Yeah, and I'm helping.
This person isn't doing anything.
No, I'm not. I'm helping him right.
That's right, you're not.
Yes, I am.
No, you're not.
You're sitting there
At
with
least
your.
the spring
They
held
call
out
it
this
the.
time.
They call it.
Dang.
Oh, good. Sam's been watching my sweater for like the last century.
Is that on?
Yeah, it really is.
Aw. I think we haven't made any lame remarks, Christina. Who knows what we actually say when we don't pay attention?
Like, oh man.
33.
It's 100.
Bye, Sam. Sorry, it was chaotic, but graph it and find a